Guys, we're in solving systems of equations. On Friday, we got a worksheet. There's 4 problems. You can flip over on the back and see the answers. If there's not a specific one you want me to work, I'm going to work number 3. Does anybody would like to see anything other than number 3? All right. So the first thing we have to do, guys, is we have to write the equations down. And so in this particular problem, I have 2 equations. I got x minus 4y equals negative 16. And then my other equation is 5x plus 4y equals negative 8. Now, I don't want you to forget about this. Look up here, please. Okay. If I could solve these using another method, elimination would be a good method to solve this problem by. Because look, I've got 4y and positive 4y. I know that if I counted those, or if I just added those together, they cancel out. So that would be a choice. But because the directions in this particular problem say they want us to solve for y and graph, I need to solve these equations for y. So the first thing I want to do is I want to subtract x from both sides. Now, negative 16 minus x. Can I do anything with negative 16 minus x? Can I combine those? Why not? Not like terms. Good phrase. Okay, so they're not like terms. So now the next thing I want to do is I want to write those out in some order. Either I write them out in negative 16 minus x, or I write them in that order that we've been talking about, which is negative 4y equals negative x minus 16. Again, notice I'm trying to keep them in the form mx plus b. And I divide by negative 4, I divide by negative 4, and I divide by negative 4. Now, a little preview, guys, a preview for about a week from now. A week from now, this right here, where I divided by a negative 4, this is going to be a less than, we're going to be solving systems of inequalities. So it's going to be a less than or a greater than or greater than or greater than or equal to. And then what, when I divided by a negative, would I have to do to that number right there?
Change around.
Yeah, I'd have to flip the symbol. So now, it's not that, and so I write 1/4 x plus 4. So now, I want to go to my graph, and I want to graph 1/4 x plus 4. So I go to 4, and I put a dot. And then I go up 1 and right 4. Okay, and this is a picture of the solutions for the equation. Y equals 1/4 x plus 4. All right, now, the second one that I do is not quite so difficult because I don't have to keep up with signs as much. When I subtract 5x from both sides, I got 4y equals negative 5x minus 8. Again, being aware to write them in slope-intercept form. Divide by 4, divide by 4, divide by 4, and y equals negative 5/4 x minus 2. Up here, please. Where's the first place I go? Very good. Negative 2. Okay, so now I'm going to go to negative 2, and my slope is 5/4. It seems to me that because the slope is negative, I might want to go down 5 and over 4. That's right. I can go up 5, 1, 2, 3, 4, 5, and left 1, 2, 3, 4. And then again, guys, it appears to me that I have a good lattice point. I have a good lattice point for my solution. And a lattice point is a point where they cross nicely and on the...
Negative 4, 3.
That's right. So that's the coordinates, negative 4, positive 3. Now, what I would do if I was conscientious about this, and I really want to make sure I'm getting them right, is I would come over here and I would take negative 4, 3, and plug it in. Well, negative 4 minus 12 Negative 4 minus 12 is negative 16. So the point negative 4, 3 solves that equation. Guys, this stuff is kind of cool to me. And the reason I think it's so neat is, guys, I think we are literally finding a needle in a haystack. And here's what I mean by that. Look, how many solutions are there, and use a math term, how many solutions are there to this black equation right here? Yeah, there's an infinite number of solutions. Guys, I could keep calling out coordinates. I could keep calling out coordinates of all those points. I could do the same thing to this blue line. I could keep calling out coordinates for this blue line. And every one of these x's and y's would do what to this equation? Make it true. What the red equation or dot does, what this red point does, guys, the coordinates of that red point are the one point. This has an infinite number of solutions. The blue line has an infinite number of solutions. The red dot is where they intersect. And I can see that negative 20 plus 12 is negative 8. So negative 4, 3 solves that equation as well. So negative 4, 3 solves both equations. It's where they intersect. That's what we're looking for. 2 days from now, look up here, please. 2 days from now, if you will go to my website, you'll see a good preview here on my website. This is, in the middle of the page here, is a solving system by graphing presentation I'm showing you right now. Down at the bottom of the page, there's a video here you need to watch on classifying systems of equations. Because 2 days from now, hold on a second, go. 2 days from now, when we solve systems of equations, these lines aren't going to always cross. What would cause a pair of lines to not cross? Why?
That same slope.
But different y-intercepts. The y-intercepts will be different. If they have the same slope and different y-intercepts, they end up being parallel. And a parallel system has no solution.